So for my project, my ball is able to collide with uh, uh so for my project, my ball is able to collide with the borders, yeah, and the collision between the white ball and the other colors. The holes are also working, and if yeah, so actually, the non-white ball is also able to collide with each other. So for the ball 2D script, we're actually at start, we will take the current ball position and put it into this new position. And then we take the sprite and then we'll, as this is a, a world size sprite, it's not in, sorry, world space sprite is not in the local space. So we want it into a local space. So we actually have to do, um, we have to take the local sprite size and then we divide it by the pixels per unit. Yeah. So in order, sorry, it as this is in the world space, this is not in local. So in order to get the local space, we will actually have to do the uh take the world space minus the, sorry, divide by the pixels per unit. Yeah, so we actually do this for like the radius of the ball, the radius of the ball sprite, and um the sprite uh to render the world space units. And then we actually also have the left wall, right wall, top wall, bottom wall, which we actually put game object dot find with the naming here. So we'll find the object through its names. So left will be here, the left wall. And then the wall offset also is used, we also put it here to take the sprite itself and render it into world space units from top wall. So for the ball 2D physics, we update the ball with the parameter of delta time. So for the velocity of x, it will actually times it per delta time. So it will actually happen between each frame, and this will give us the displacement. So for the position, we actually take the we plus equals the negative displacement. And then we give this ball this new position after we have minus of the displacement itself. So we also have this util class. So for this util class, we actually use it to find the distance between the two positions. And this is using Pythagoras theorem. So let's say we have a triangle. We'll be wanting to find the hypotenuse. So we'll take the xy position of here and here. So we get sorry, we will try and get the hypotenuse by taking this position. So let's say this is A and this is B. Yeah. So uh A square plus B square, we square root it, we get the answer to find our hypotenuse. And then we use this test 1, 2, 3, 5, test out the distance. And it works. And then this is colliding with, it's used to find if there's an input inside the ball that's colliding. So with the parameters of x and y, which is actually what we're going to use for our mouse input. Yeah, so we actually take this is colliding with, and then we find the distance between the ball itself and our x and y axis. And then we return the distance if it's less than or equals to the radius of the ball itself. So for the handle boundary collision, we actually use it to declare the boundaries that the ball cannot go out of. So let's say we have this ball inside here, and we have the ball left. Yeah. So if the ball left over here is uh and the left wall here, yeah. So we take the wall offset, which we've already set on top, and then if velocity equals to more than 0 f, sorry, if velocity is less than 0 f, we actually take the left wall the left wall position, and then we plus the wall offset plus the radius. So the reason why we do this is so that the ball wouldn't just go through all the way as we're taking the x-axis, and then since this is on the left, we actually have to plus the x itself. So for the right, you actually minus it. So for it's colliding with two, we check if two balls are colliding with one another by taking ball's A position minus the the other ball's position. So with that value, we get this magnitude to get a value, and then we compare if that value itself less is smaller than the radius of both balls. So its colliding with hole is used to check if there is a collision between the hole itself and the ball. So we take the ball position minus the other, which is the hole. And with that value, we get the magnitude also, and then we see if it's lesser than the hole radius. So if the ball radius, sorry, if the value between the ball and the hole is smaller than the hole radius. So for void update, we actually take the displacement. So we do it pretty much in between every frame rate. Sorry, we do it um every frame. Yeah, so the displacement x and y, we take the velocity times time delta time, which is the time between each frame, and then we take the velocity minus equals to velocity times time dot delta time in order for the friction to work, as velocity equals to velocity minus velocity times time after every frame, which is time dot delta time. That's what this code means. This is used in order to lessen the velocity after each frame rate. And then we take the transform dot translate uh, new vector to the x and y position in order to move the ball to the new position and distance. Sorry, and direction. Distance and direction. We then have this fixed update, which is used to handle collisions, which I've talked about on top, as well as the update ball to d physics, which is using time dot delta time, which is the time between each frame. And then we also have this to to declare where the ball's hot position, the ball's bottom position is at all times, because the ball will keep moving around. So we have to put it in fixed update in order to get the position non-stop. And for whole 2D, we just get its position, and then we put the x and y axis on it, and then we try and render it into the local sprite size, local space. So for the pool cue, we take this third party thing called line draw, and we use this in order to draw outline for the cue itself. So whenever we touch thing, there will be a line. So if you press our left mouse button, we will actually create this uh, start line position, which is actually the input of our mouse itself. And then we take the ball, if ball not equals to null, so if there's something inside the ball and the ball is colliding with the input, so if something is inside the ball, we will draw this line. So we take the line, and then we take the start, the end, and then we take the size of it and the color. And then we'll enable it to be true so that it can be seen. And else, if we get our mouse button up, we So once we let go of the thing and draw line is not equals to null, so the draw line is still happening, we will disable it by putting false. And then since we want the ball to actually uh, get its velocity from how far back we pull the the pull Q, we actually create this H vector 2D, which we take the input minus the ball position to get this velocity, and then this will allow our ball to move the our ball to have the velocity depending on how far we pull back. And if draw line is not happening, the draw line dot n equals to our position, our mouse input, because this is in order for us to draw the line over and over again, as if we do not have this, we will not be able to draw the line again. So it will only happen once. So it's pretty much to update the position of the line every time. So for my table 2D project, so for table 2D, we actually spawn the balls at random positions by iterating through the balls list. And then to make sure it spawns at the empty spot within this screen playing field. So the screen playing field will be here. And so we also have this temporary vec, which is we just put the create like our B dot transform the position in order to get the game object's position. And then we give this the after we put in the random range, so it's random after we randomize it, then we give it a new we give this game object this new position, and then we put this ball into this new position. And then while doing this, we also check that the check ball collision is there, so in order to make sure that it doesn't spawn together, so there will not be any collision between there will not be any balls that collide like overlap each other. So for check ball collision, we use ball 2D to check, and then we check if uh, two balls are in each other's radius, and if to check is not equals to ball, then it return true, else it return false. So for the update, since it's happening every frame, we will iterate through the balls list. We will check if any two balls are colliding, because if if ball not is not the same as ball 2, then we'll check if the ball is colliding with ball 2. And if it is colliding with ball 2, then we'll handle the collision. We will uh, start doing the handle ball collisions. We will take in the ball 1 and ball 2. So while this is happening, we will also check if they actually go into the holes every update. So for these holes, if it's colliding with the hole itself, the ball will actually be deactivated, and then it will break after, as we don't want this, we'll break this loop after it's set after it deactivates. And for the handlebar collision, we take in the uh, we'll do the math behind it in order to get like how it will actually bounce back. So if both balls are going this way, we have to make sure it's going this way. So in order to find that, we have to uh, take the v1, the v1 prime, and then the minus v1, v1 prime project, and then the minus v1 prime project. So we have to plus these three in order to get this. So after that, we'll set our velocity to that, our velocity to this v1 prime in order for it to collide. In order for it to bounce uh in the other direction. And for this adjust ball distance, we will actually find out how much they're overlapping, and if two balls are overlapping, they'll move back to uh, before they collided, and we do that by calculating how much the distance they have to move back and the displacement. So if distance to move back is not the same as zero, the ball position will actually take the ball position minus the displacement in order for it to move back.